Hi students, this is the movies for Chapter 4. In Chapter 4 we're going to be reviewing how to apply dimensions and limits of size to drawings. It's kind of a review, but it sets up what we're going to be doing in GD&T. So let's start with our objectives. Objective 1, clearly apply dimensions in drawing views by complying with the stated general dimensioning guidelines. Number 2, apply dimensions to any of the geometric shapes commonly found in mechanical parts. Number 3, cite the standardized types of fits for inch dimensions and describe the general conditions associated with each. Number 4, we're going to introduce rule number 1 and rule number 2 of GD&T, the ASME Y14.5 2018 standard. And number 5, we're going to provide examples on the effects that dimensions and tolerances have on manufacturing. And then please see your objective sheet for the terms that we're going to look at in this lesson. Okay, let's start with some definitions. Feature of size. A feature of size is a feature on a part drawing or a part that has a single size dimension. It could be a thickness, it could be a width, it could be a length, it could be a diameter, like a hole diameter, or a cylindrical diameter, or it could be a spherical diameter. These are features of size. And those would be considered regular versus irregular, which is in like a one enclosed shape or a collection of features that combine. We mostly talk about regular features of size in this class. First of all, let's talk about prisms and pyramids. A right rectangular parallelepiped, that's a prism, formed by 6 flat surfaces. Only 3 dimensions are required. You got length, width, and height. For a pyramid, a right square pyramid has 5 points that must be dimensioned. So we have, the base, the width and the thickness of the base, and also the height, and then the location of where the point is located. Those are the dimensions you would need to fully define a pyramid. Now let's talk about cylinders, and this is specifically how they're dimensioned in models. Okay, so what you can do in a model is you can attach these dimensions to the model as so. You're going to use a diameter symbol, and then you're going to bring this down with a liter. Liter and dimension values are placed in the same annotation plane. It's kind of beyond the scope of what this course is, but the annotation plane is like the plane that they're putting these dimensions on. We're not going to be dimensioning models in this class. I mean, if anything, we're going to be doing dimensioning drawings. And that's pretty much from just the assignments and stuff like that. Okay, so the annotation plane must contain cylinder axis or lie perpendicular to the axis. So in this case, this annotation plane lies perpendicular to the axis of this cylinder. Now if we're talking about orthographic views, here's how we dimension it. A diameter symbol with length required. Okay, so here's right here we got a diameter symbol with length required, but it's preferable to be dimension these in preferable to dimensions on the non-circular view. See how that one is right there. Diameter dimension usually between non-circular and circular views. Okay, so what they're saying here is it's best to do these cylinders in the non-circular view and to put these dimensions between the two views. Really, this is one of those cases where, if we didn't have this orthographic view, we could still entirely dimension the part with this one view. And that's applicable for a cylindrical part, such as this one. Flats on cylinders. Here's how we dimension a flat on the cylinder. We need to dimension the depth of the cut, and that's usually dimensioned from the back side, and then the length of the cut, and that's usually dimensioned right up in here. So cut into cylinder provides surface suitable for clamping something in a fixed location. Dimension from the cylinder's far side to the center line. And just that. Cones. A right circular cone or an oblique circular cone. Okay, so we got a conical shape here, and for a right cone all you really need is the diameter and the height. and the angle. Yeah, actually you need either the base diameter and the cone height, or you need the base diameter and the cone angle. Either one of those will do. So this, we got two ways to represent it. This one and this one. This one shows the height, and then this one shows just the cone angle. Now, if you have an oblique circular cone, you need the base diameter, the cone height, and the apex offset. So base diameter, cone height, apex offset. Hole size in models. Okay, dimension by a giving a diameter. It's applied by a note and a leader on one annotation plane coincident with the penetrated surface. Let's see, this annotation plane's right here on the surface. And it may be necessary to apply dimensions to hidden features, like we're showing over here. Now, hole size in orthographic views, there's several ways to do that. It's dimensioned by giving the diameter, and large holes dimensioned by placing the dimension line and size value inside the hole. Okay, so here's an example. We've got a large diameter here, and we put the dimension inside the hole. This is a smaller diameter, so we put the dimension outside the hole with the dimension line inside the circle. Here we got two different cases. We have the inside diameter here of this tube, and it's dimensioned with the dimension lines inside the circle. And here's the outer diameter. The dimension lines are placed outside. And then here we have a diameter 0.62, and we're just doing this with a leader, so that's valid as well. In this case, we got a counter bore, and we're showing them in this section view. Okay, so dimension by giving the diameter. Large holes are dimensioned by placing dimension lines in the size valve inside the hole. Dimension lines must pass through the center of the hole. Small holes are dimensioned with leaders connected to the size value. Leaders point towards the center, but terminate at the edge of the hole. That is this one here. Leaders pointing towards the center, but it terminates at the edge of the hole. And we may specify hole diameters in non-circular views when shown in a section view. And that's what we're showing right here. And again, it's very important to use the diametrical symbol when you're dimensioning a hole, always. And it's more important to use the diametrical symbol here when you're dimensioning the hole not in the round view. Okay, so holes also have locations. So hole locations are dimensioned to the center of the hole. Extension lines apply to the hole center and extend past the dimension lines. Center lines are drawn between the holes when a single dimension locates multiple holes aligned with each other. Let's take a look at that. We have a center line between the locations here. Okay, because what we're doing is we're locating both of these holes with this 0.75 dimension. Okay, so when we're crossing the object lines here, we have a extension line, and it crosses this object line. It does not break. Okay, and the extension lines are not broken at the object lines either when they cross here at this point. And then the locations of the hole centers are dimensioned. Okay, so that's what we're doing with that. Hole depth. This is a tricky one because in some cases you don't really know when to use the words through or not. It's kind of nebulous, but a hole is assumed to go through the part in orthographic views unless a depth is specified. So like in this particular case, you don't really need to say through, but you want to use the word through following diameter if it could be misinterpreted. The through hole is not necessary for models because you can see on the model that the hole goes through. That's really not such the case in a orthographic projection. The depth symbol precedes the specified depth. So you're going to specify the depth for blind holes. There's blind hole, and it always goes to the full diameter. Okay, and you use that depth symbol, and then the dimension of the depth is afterwards. and you want to specify the total depth where the hole passes through multiple walls. Okay, I'm going to end this movie here, and we'll pick it up with the next one in the next movie. Thank you.